In this learning module, we're going to talk about the laws of exponents. Now, these can be a little confusing because there are quite a few, but hopefully we can break it down for you and make it understandable. So, what you see here are just definitions. Notice the exponents have letters like N and M. This is for the sole purpose of just showing you what operation you're going to perform between these exponents. So, when you have terms that you're multiplying together where the base is the same, they both have an x. What happens to the exponents is you add them together. So in this case, x to the times x to the m power, you're going to get x to the n plus m. Now again, these are just definitions. We'll go through examples as we go. In the second one, what we want to do is we have variables being divided. These variables also have exponents. So if you think about it, in the previous one, we added the exponents because we were multiplying. In this case, we're dividing. So what we're actually going to do is subtract the exponents. It's the exact opposite of the above one. Again, these are only definitions. For the third problem, we have x to the nth power being raised to the mth power. So I call this power to power. So before we added the exponents, we subtracted the exponents. What do you think is left to do with the exponents? In this case, we're going to multiply the exponents. Now, besides these three rules, there are quite a few more. And one of them includes dealing with negative exponents. When you're simplifying, solving a problem, you never, ever, ever want to leave the variable or the number with a negative exponent. Now, x to the negative nth power, this is written as a whole number. So in order for you to visualize this, I'm going to write it as a fraction over 1. The only way to get rid of this negative exponent right here is to flip it, find the reciprocal of it. So in this case, x to the negative n is in the numerator. In order to get negative n to be positive, we want to put x to the n in the denominator. So what happens is my answer becomes 1 over x to the positive n. So once you flip it, it was in the numerator, I put it in. Once you flip it, notice I'm not writing the negative sign anymore. That movement is what made that exponent positive. So if you look down here at number 6, notice that the negative exponent is in the denominator. So same property, it's already written as a fraction. So what's going to happen is, in order to make this negative exponent positive, I need to put x to the n in the numerator. The same way that in number 4, I brought it down to the denominator. So what's going to happen here is, n, I'm going to get x to the n over 1, which in turn is just x to the n. Again, notice, once I brought this term from the denominator up to the numerator, it's now positive. So let's start applying these definitions to some problems. In this first problem, we have x cubed times x to the 4th. Since both terms have the same base and they're being multiplied, our job is to simply add the exponents together, which is going to give us x to the 7th. Let's look at the second one. The second one is x to the 4th divided by x cubed. Our laws of exponents say that we're going to subtract the numerator exponent. We're going to say the numerator minus the denominator. So in this case, we get x to the 4 minus 3, which leaves us with x1. In the third one, we have x to the 4th raised to the 3rd power. This is that power to power rule. Again, we already added the exponents and subtracted. The only thing that's left is to multiply. So x to the 4th and 3, we get x 4 times 3, which gives us x to the 12th. Number 4 has our negative exponent. We never ever want to leave our answers negative with a negative exponent. So again, I'm going to put this whole number variable over 1 so it can look like a fraction, so that I actually have somewhere to move this negative exponent. Again, since the x to the negative 4 is in the numerator, I need to move that term to the denominator in order to make that exponent positive. So what happens is I get 1 over x to the 4th. For number 5, x to the 0 power, the only thing that you need to remember about this is anything, I don't care if it's 1,000,000, 0.5, 1/2, anything raised to the 0 power is going to become 1. Simple as that. No ifs, ands, or buts about it. Number 6, again we have another negative exponent. This time it's in the denominator. So again, in order to make this negative exponent positive, we need to move this entire term, x to the negative 4, into the numerator. So this answer becomes x to the 4th, and it could be over 1, but again, you can just write x to the 4th. Now that we've looked at the definitions and some simple examples of laws of exponents, let's start looking at problems where they use the laws of exponents in combination with each other. In this first problem, if you remember, when you have a power raised to another power, you're going to multiply those exponents. But the mistake that students make here is they forget to cube the number. So what happens is this exponent needs to be raised to both of these, the 3 and the x squared. So the problem becomes 3 cubed times x squared times 3, because you're going to multiply the 2 and the 3. So 3 cubed gives me 3 times 3 times 3, which is 27, and then x, 2 times 3, gives me x to the 6. In this second problem here, we're going to use the quotient rule. We're going to subtract our exponents, and remember to only do it with the letters that are the same. So for instance, I'm going to subtract 8 minus 2 because those are the exponents for my variable x. And then I'm going to subtract 2 minus the exponents for my variables y. So what happens here is I get x to the 8 minus 2 and y to the 2 minus 6. So let's work that out. 8 minus 2 is 6, so I get x to the 6. 2 minus 6. Now this goes back to learning module number 1, where you have to keep track of your signs. You have a positive 2 and a negative 6. So in this case, you're going to subtract and get 4. And you're going to take the sign of the higher number, which is negative. Now this rule, even though we did one law already, which was the quotient rule, now we have a negative exponent. You never ever ever want to leave your answer with a negative exponent. So just like we did before, we're going to put the term over 1 so that this negative exponent actually has a place to go. Now in order for y to the negative 4th to become positive, we need to rotate that entire piece to the denominator. Now I'm going to leave x to the 6th in the numerator because 6 is positive, so we don't need to change that. But y to the negative 4th is going to become y to the 4th in the denominator. Now this last and final one, we have a couple different laws going on at the same time. So the first thing we need to do is distribute this negative 2 on the outside of the parentheses to everything that's inside, to the x squared, to the y, at the bottom, to the x, and to the y squared. So after we do that, we're going to get x to the x squared times negative 2 is going to give us x negative 4. Y to the negative 2 is going to give us y negative 2, and that's because when there is no exponent, you can assume that the exponent is 1. So if you think about it, 1 times negative 2 gives me negative 2 over x to the negative 2. Again, x does not have an exponent, so you can assume that it's 1. 1 times negative 2 gives me x to the negative 2. Y squared to the negative 2 is going to give me 2 times negative 2, which is going to give me y negative 4. Now once you get here, there's a couple different things you can do. It really is a preference. It's not like order of operations. I can either, 1, use my quotient rule and go negative 4 minus a minus 2 and negative 2 minus a minus 4, or I can flip everything, get rid of all the negative exponents, and then do the quotient rule. I'm going to do that first, because if we get rid of some of these negative signs, it will alleviate us making mistakes. So x to the negative 4 is going to go in the denominator. Meanwhile, x to the negative 2 is going to go in the numerator. And the reason we're doing this is because they're both negative, so they both need to move. Y to the negative 2 is going to come down into the denominator, and y to the negative 4th is going to go up into the numerator. So let's rewrite the problem with these changes. I'm going to draw my fraction line so you can see. First, I'll move x down to the bottom, which is in the denominator, and x to the negative 2 in the numerator. Notice when I rewrite these terms, the exponents are no longer negative, and that's because we flipped them in order to get rid of the negative exponent. Y to the negative 2 is now going to be in the denominator, and y to the negative 4 is now going to be in the numerator, but again as positive exponents. Now that all the exponents are positive, it would behoove you now to use the quotient rule, which is to subtract the exponents to completely simplify this problem. So the next answer that you should get should be, you got x squared divided by x to the 4th. That means I'm going to have x 2 minus 4, 2 minus that 4 right there. And then for the y's, I'm going to have y 4 minus 2. Let's work this out. So next I'm going to get 2 minus 4 is going to give me x to the negative 2. Y 4 minus 2 is going to give me y squared. So again, we're still not finished because we have that negative exponent. We need to draw this over 1 so that the negative exponent has somewhere to go, and rotate x to the negative 2 to the denominator so that exponent will become positive. So my final answer is going to be y squared because I don't need to move that. It's already positive. And x to the negative 2 now is going to be in the denominator.